Welcome to G Fun Facts Online. Let's talk about the future of robots. When you picture this future, what do you see? Do you imagine a world of cold, unfeeling machines taking over human jobs? A vision straight out of a dystopian movie. For decades, that's been the dominant narrative. The robot as a servant, or worse, a rival. But what if that entire concept is wrong? What if the future isn't about replacement, but about partnership? A deep, intricate, and powerful collaboration between human and machine. This isn't science fiction anymore. It's the burgeoning field of symbiotic robotics, and it's poised to change everything about how we work, heal, and explore. Symbiotic robotics represents a fundamental shift away from the old master-servant dynamic. It envisions a future where robots don't just execute our commands, they work with us, augmenting our physical and cognitive abilities. Think less of a factory arm mindlessly welding a car door, and more of a sophisticated partner that anticipates your next move, helps you perform a delicate task, and even learns from you. So how do we build these partners? It's not just one single breakthrough, but a convergence of several incredible technologies. First up are the stars of the show, collaborative robots, or cobots. Unlike their industrial ancestors, which were locked away in safety cages to prevent them from harming human workers, cobots are designed from the ground up to operate safely in shared spaces. They're equipped with advanced sensors, like torque sensors and computer vision, that allow them to detect a human's presence. If you accidentally bump into one, it will stop instantly, preventing injury. This allows for a completely new kind of manufacturing, where a human worker might handle the fine motor skill parts of an assembly, while the cobot partner does the heavy lifting or repetitive fastening. The human provides the dexterity and problem solving, the robot provides the strength and stamina. But being safe isn't enough. To be a true partner, a robot needs to be intelligent. That's where artificial intelligence and machine learning come in. Modern robots aren't just programmed with a fixed set of instructions. They learn. Using techniques like reinforcement learning, a robot can learn the best way to perform a task through trial and error, just like a human. It might try thousands of different ways to pick up an oddly shaped object, receiving a virtual reward for each successful attempt, until it masters the technique. This learning capability allows robots to adapt to new situations and even predict human intentions. A symbiotic surgical robot, for example, could learn a surgeon's specific techniques and preferences, subtly steadying their hand during a complex procedure or anticipating which instrument they'll need next. It's about creating a seamless workflow where the robot feels like an extension of the surgeon's own body. Now, let's scale up. What if the collaboration isn't just one human and one robot, but one human and 100 robots? This is the concept of swarm intelligence, and it's directly inspired by nature. Think about an ant colony. No single ant has the blueprint for the entire nest, and there's no leader giving orders. Instead, each ant follows a simple set of rules and interacts with its neighbors. Out of these simple local interactions, incredibly complex and intelligent group behavior emerges, allowing them to find food, build structures, and defend the colony. We are now applying this same principle to robotics. Imagine a disaster scenario, like a collapsed building after an earthquake. Instead of sending in one large, expensive, and potentially clumsy robot, you could deploy a swarm of hundreds of small, cheap, insect-like robots. They would spread out into the rubble, communicating with each other wirelessly, collaboratively building a 3D map of the structure, identifying safe passages, and locating survivors far faster and more effectively than any single unit ever could. This same swarm logic can be applied to agriculture, with swarms of small drones monitoring crop health plant by plant, or in warehouses, where fleets of robots coordinate to sort and move packages with incredible efficiency. This inspiration from nature also extends to the physical bodies of the robots themselves. For decades, robots have been made of rigid metal, but nature is soft, flexible, and resilient. This has given rise to the field of soft robotics. Instead of gears and motors, soft robots use materials like silicone, rubber, and flexible plastics, often powered by air or fluid pressure. This makes them remarkably adaptable and safe for human interaction. Imagine a soft robotic gripper modeled after an octopus tentacle. It can conform to the shape of any object, allowing it to pick up a delicate piece of fruit without bruising it, or a slippery, irregular object that would baffle a traditional metal claw. In healthcare, these soft robots could be used for gentle rehabilitation exercises, or even as internal medical devices that can navigate the delicate pathways of the human body. Of all the technologies enabling this new symbiotic age, perhaps the most profound is the concept of the digital twin. A digital twin is a perfect, high-fidelity virtual model of a physical object, process, or system. It's not just a static 3D model. It is a living, dynamic simulation that is constantly updated with real-world data from its physical counterpart. The relationship is symbiotic. The physical robot, covered in sensors, works in the real world. The data from these sensors, its position, what its cameras see, the forces it's exerting, is streamed in real time to its digital twin. This keeps the virtual model perfectly synchronized with reality. But here's where the magic happens. In the digital world, you can do things that are impossible, expensive, or dangerous in the real world. Let's say a factory wants to introduce a new cobot onto its assembly line. Before the physical robot even arrives, they can use its digital twin to simulate the entire new workflow. They can run thousands of simulations to find the most efficient layout, test safety protocols, and train the human operators on how to interact with it, all in a risk-free virtual environment. By the time the physical robot is switched on, the process is already optimized and proven to be safe. Perhaps the most stunning example is how NASA can use this technology. They can create a digital twin of the entire Martian surface, built from satellite and rover data. Back on Earth, they can use this virtual Mars to test and train a rover's navigation algorithms. The digital rover can try to climb 1,000 different risky paths, and if it crashes or gets stuck, it doesn't matter. It's just a simulation. Through these countless trials, the AI finds the optimal, safest routes. These proven strategies are then uploaded to the real rover, millions of miles away on Mars. The digital twin becomes a shared mental model. It provides a common ground for humans and robots to understand each other. A human operator can look at a screen showing the digital twin and see exactly what the robot is seeing, what it's planning to do next, and why. This dramatically improves situational awareness and, crucially, builds trust. You're no longer just giving commands to a black box, you are looking into its mind. The applications of this symbiotic future are vast. In medicine, surgeons will have their hands steadied and their abilities augmented by robotic partners. In manufacturing, human creativity and robot efficiency will combine to create new products. In exploration, astronauts on the Moon or Mars will work alongside tireless humanoid companions, sharing the burden of discovery. This is not a world where robots replace us, but one where they work with us. It's a future of augmentation, where human intuition and robotic precision become a single, powerful force. Of course, the journey there is not simple. The technical challenges are immense. Creating truly intelligent, adaptable, and reliable systems is one of the hardest problems in engineering. Ensuring absolute human safety in these close-quarter collaborations is non-negotiable, and we must grapple with profound ethical questions about job displacement, privacy, algorithmic bias, and who is accountable when a symbiotic system makes a mistake. These are not afterthoughts. They are conversations we must have now, carefully and inclusively. Yet, the momentum is undeniable. Propelled by exponential advances in AI, sensors, and materials science, the building blocks of this symbiotic future are rapidly falling into place. The fusion of mind and machine, of biological and artificial, is beginning. The task before us is not just to build these intelligent machines, but to do so with wisdom and foresight, ensuring this new and intimate partnership is one that truly benefits all of humanity. The dance has just begun, and the steps we choreograph today will determine the shape of our shared future for generations to come. Thank you for joining us on Fun Facts Online.